In this video, I want to talk about isomerism in cycloalkanes or isomers in cycloalkanes. So as you remember earlier in other videos, I talked about alkanes isomers. So open chain alkanes undergo rotations about their carbon-carbon single bonds. So they are free to assume any of the infinite number of conformations. So basically they can rotate anywhere that they want. So the theta, as you saw earlier, it was changing from 0 to 60. It can assume any kind of theta. On the other hand, we had alkenes. Alkenes have rigid double bonds that prevent rotation, giving rise to cis and trans isomers. So we have two isomers called cis and the other one is called trans. Isomers with different orientations of the groups on the double bond. Cycloalkanes are similar to alkenes in this respect, and the cycloalkane has two distinct faces. If two substituents point toward the same face, they are cis. If they point toward opposite faces, they are trans. These geometric isomers cannot interconvert. It means that it doesn't change by itself. So it has to be in a process of breaking and reforming some bonds. So these geometric isomers cannot convert without breaking and reforming bonds. So we need to decompose those bonds and reform a new bonds to have a new isomer. From cis to trans, for example, or from trans to cis. So here we have some examples for cis and trans. On the top one, we have cis 2-butene and trans 2-butene. That's the example for alkene. As you see here on top one, we have methyl group in the same side, same face. That's why we have cis. And this one, they are in two opposite way. So that's why we have it trans. Now for cyclopentane or 1,2 dimethyl cyclopentane, we have methyl groups in the same side and the opposite side here and here. Okay, so here we have trans isomer, here we have cis isomer. So that's why we need to write cis 1,2 dimethyl cyclopentane, and this one trans 1,2 dimethyl cyclopentane.